Chapter 2 Review Key. Question 1, we have 8j minus 5 plus j equals 67. First step, we want to combine like terms. So 8j and positive 1j become 9j minus 5 equals 67. Then we'll add 5 to both sides. We've got 9j equals 72. We'll divide by 9. And we get j to equal 8. Question 2, negative n plus 8.5 equals 14.2. We'll start by subtracting 8.5 from both sides. We've got negative n equals 5.7. We'll divide by negative 1. We get n to equal a negative 5.7. Question 3, we have 6 times the quantity t plus 5 equals negative 36. We'll start by distributing 6 throughout. We've got 6t plus 30 equals negative 36. From here, we want to undo the addition of 30 through subtraction. So we subtract 30 from both sides. We end up with 6t equals negative 66. Then we'll undo the multiplication through division. So we divide by 6, and we get t to equal negative 11. Question 4, we have 7h plus 2h minus 3 equals 15. We're going to start this one by combining the like terms. The 7h and the 2h become 9h minus 3 equals 15. We'll undo the subtraction of 3 by adding 3 to both sides. We get 9h equals 18. We're then going to divide by 9 on both sides of the equation. We get h equals 2. In question 5, we've got 7/12 times x equals 3/14. You have two options here. You can divide by 7/12, which you'll need to use parentheses for if you're going to do that with your calculator. Or you could also multiply by the reciprocal, which in this case would be 12/7. Regardless of how you approach this problem, you're going to get x to equal 18/49 if you reduce it, or right around 0.367. Question 6, you've got 8g minus 10g equals 4. We're going to go ahead and combine like terms here. Positive 8g, negative 10g gives us negative 2g equals 4. We'll then divide by negative 2. And we're going to get g to equal negative 2. Question 7, 3x plus 4 equals 5x minus 10. We've got variables on both sides, so we're going to gather our variables on one, constants on the other. So I'm going to start by, let's subtract 3x from both sides. So now we've got 4 equals 2x minus 10. Now I'll add 10 to both sides. I've got 14 equals 2x. My last step will be to divide by 2. And I get x equals 7. Question 8. 2a plus 3 equals 1/2 the quantity 6 plus 4a. I'm going to distribute the 1/2 throughout. Well, half of 6 is 3. Half of 4 is 2. So I've got 2a on the right. 3 plus 2a on the right equals 2a plus 3 on the left. Right here I notice that both of these quantities are actually the same, but I'm going to keep going just to see how this turns out. From here, I'll subtract 2a from both sides. On both sides of the equation, the variables disappear, and I'm left with 3 equals 3. And just as I thought, this is a true statement, so I have infinitely many solutions, or I can say the identity. Question 9, 7 times the quantity 6 minus 2a equals 5 times the quantity negative 3a plus 1. we'll start by distributing on the left. So this becomes 42 minus 14a on the left. And then I distribute on the right as well, which becomes negative 15a plus 5. At this point, I want to get my variables on one side, other numbers on the variables on one side, constants on the other. So I'll start by adding 15a to both sides. I've got 42 minus a, or actually 42 plus a, sorry, equals 5. From here, I'm going to subtract 42 from both sides. And I get a equals negative 37. Question 10. A lawyer charges $100 per month to be put on retainer. So that means it's just like the base fee every month. The lawyer also charges an hourly rate of $75. How many hours does the lawyer have to work for a client in 1 month to charge a total of $625? So the unknown quantity here is hours worked. So to set up this equation, we have to think about what's taking place. They want to charge a total of $625, and that needs to be equal to the retainer or the base fee of $100 plus the hourly rate. And so we'll just solve this for h in order to determine how many hours had to be worked. You would subtract 100 from both sides and then divide by 75, and then you get that it's going to be right around 7 hours, or it's exactly 7 hours, is how many hours had to be worked. Question 11. You spend half of your allowance each week on school lunches. Each lunch costs $1.25. How much is your weekly allowance? So the unknown amount here is an allowance. So we'll let A be the allowance. We know that half of the allowance is equal to how much you spend on school lunches. Well, there's usually 5 days of school per week. So we'll take 5 times the cost of each lunch, which is $1.25. So right now I've got 1/2 A equals $6.25. To solve this problem, I can either divide by 1/2 or multiply by the reciprocal, which is 2, and I should get that the allowance is equal to $12.50. Question 12. We're going to solve 6p plus 1 equals 3 times the quantity 2p plus 1. So I'm going to start by distributing on the right. That gives me 6p plus 3 equals 6p plus 1. First step, I'm going to go ahead and subtract 6p from both sides. At this point, I notice that my variables cancel out, and I'm left with 1 equals 3, which is not true, so this is no solution. Question 13, I'll distribute the 2 throughout. So I've got 2 times 3x, which is 6x. 2 times 6 is 12. And then I distribute the 3 throughout, so that gives me 6x minus 12. The two quantities appear to be identical, so I'm probably dealing with an identity, but let's go one step further. I'll subtract 6x from both sides. I'm left with negative 12 equals negative 12, which is true, so that means I have infinitely many solutions. And then question 14, I've got 3 times the quantity g minus 1 plus 7 equals 3g plus 4. I'll distribute through the parentheses. I've got 3g minus 3 plus 7 equals 3g plus 4. I'll combine my like terms here. I've got 3g plus 4 equals 3g plus 4. Since I know they're identical, I know what's going to happen here. And so I know that I've got the identity or I can say infinitely many solutions. Question 15. It asks us to solve the equation for y and then figure out the value for y for each value of x. So we first need to rewrite these so y is our isolated variable. So in 15, we're trying to solve for y. First thing I'm going to do is I'm going to subtract 4x from both sides to move the x away. Well, that's going to give me negative 2y equals negative 4x plus 15. Then I'm going to divide by negative 2 to get rid of the negative 2 with the y. And I get y equals negative 4 divided by negative 2 is 2. So 2x, and then minus 15 divided by 2 would be 7.5. So this is my rewritten equation. Now all they want me to do next is to evaluate for 2 and 4. So that means I'm going to plug in x equals 2 and then see what happens with my y value. So y equals 2 times 2 minus 7.5. Well, 2 times 2 is 4. 4 minus 7.5 is a negative 3.5. There's 1. Then I'll do the same thing with 4. So x equals 4 here. I'll get y equals 2 times 4 minus 7.5. 2 times 4 is 8. 8 minus 7.5 gives us a positive 0.5. So those are our two answers. Now we'll do the same thing in question 16. They want us to solve this for y. So we're going to get y by itself. First step, move the 18 through subtraction. So I've got 6x minus 18 equals negative 4y. Now I'll go ahead and divide by negative 4. This time I'm going to get, well, I'm just going to be able to reduce. I'm just going to go ahead and reduce the fraction, or let's use decimals. We'll get a negative 1.5x plus 4.5 equals y. So this is our equation when solved for y. And then, like the previous one, we just want to plug in the values for x. So negative 2, and then we're going to plug in 0. When we plug in negative 2, we're going to get y to equal 1.5. When we plug in x equals 0, this time we're going to get 4.5. All right, in 17, 18, and 19, they ask us to solve the equations for the given variable, or solve the formulas for the given variable. So in 17, they want us to solve for x. 18, we're solving for x, and 19, we're solving for x as well. So we're trying to get x by itself in 17. First step, we're going to subtract m from both sides. It's not multiplying by the x, it's actually being added or subtracted to it, but it's a positive m, so the only way to move it is to subtract it. And so we've got c minus m equals negative bx. Then we need to undo the multiplication by negative b, so we divide by negative b. And ultimately, we get x equals c minus m over negative b. Question 18, we're still solving for x. But to get to the x, we first have to move the y. So we're going to multiply both sides of the equation by y first. So that's going to result in x minus 3 equals wy, or w times y. Then we'll move the 3 through addition. So we'll add it to the other side. And our final answer is going to be x equals wy plus 3. And then 19, we're trying to solve for x still, but we first got to move the entire quantity underneath. And since it's a quantity of y minus 1, we can multiply by a quantity of y minus 1. So we're going to take x plus 2. Let's rewrite it. It's a little easier to see. We're going to put parentheses around it. And to get rid of that y minus 1, we're going to start this problem by multiplying both sides of the equation by the quantity y minus 1. So we see it cancel here and here. We're left with x plus 2 equals 2 times the quantity y minus 1. Now the next step would be to get rid of the plus 2, so we subtract 2. And we get x equals 2 times the quantity y minus 1 minus 2. If we want to distribute and simplify this up, we can. So let me go ahead and give myself some extra space here. Oh, there's part of the other problem. All right, and so let's say we want to simplify this up. We could distribute the 2, so that would give us x equals 2y minus 2 minus 2. We distributed this throughout the parentheses, and then ultimately it becomes x equals 2y minus 4. So both of these work, either one. Question 20. If four pizzas serve 15 people, how many pizzas are needed for a pizza party with 70 people? The very initial statement, when they're comparing two quantities like 4 pizzas to 15 people, that's clearly a ratio. So we've got pizzas over people. And they want to know how many pizzas would be needed for 70 people. So our proportion becomes 4 over 15 equals x over 70. Then to solve this, we would just cross multiply. So we've got 15x equals 280. Then we'll divide by 15. And we're going to get x to be 18.67 pizzas, or right around, or exactly 19 pizzas, because you can't order partial pizzas. So 18.67, or we'll round up to 19 pizzas. Question 21, approximately 8 out of every 25 families. So that statement clearly tells us we're setting up a ratio, so 8 out of 25. And the United States owns a dog. If you asked 90 families, so the total now goes up to 90, how many of those families would you expect to own a dog? So we're looking for the dogs. So we have families who own dogs on top over total families asked. To solve this, we would cross multiply. We're going to get 25x equals 720. We'll divide by 25. And we get that our answer is 28.8, or because we can't have decimal families, we'll say 29 families. Question 22, we have the proportion 3 over 4 equals negative 6 over m. We're going to cross multiply. So that's 3m equals negative 24. We're going to divide by 3 once we have it set up, and we get m equals negative 8. Question 23, you have the quantity x minus 3 over 15 equals 2 over 5. Once again, we're going to cross multiply. So we've got 5 times the quantity x minus 3 equals 2 times 15, which is 30. We'll then distribute the 5. We've got 5x minus 15 equals 30. At this point, we're going to solve this two-step equation, so we add 15 to both sides. We've got 5x equals 45. And the last step would be to divide by 5. And we get x equals 9. And then last but not least, 24. We've got q minus 4 over 2q minus 6 equals 3 over 7. So once again, we're going to cross multiply. We're going to get 7 times q minus 4 equals 3 times the quantity 2q minus 6. In both cases, we need to distribute the values outside the parentheses. So 7q minus 28 equals 6q minus 18. We're going to try to get our variables on one side, so I'm going to subtract 6q from both sides. I've got q minus 28 equals negative 18. I'll then add 28 to both sides. And I get Q equals 10.